Okay, so as we reviewed yesterday, all students take calculus, all trig functions are positive here, only sine, and then what's sine's reciprocal? Flip. What's the trig function that goes next to sine? Cosecant. What about tan? Tan's only positive, or tan's the only one positive in quadrant 3. What's its reciprocal? Cot. Cotangent. And then last, cosine is the only one positive in quadrant 4. What's its one that goes with? Secant, S-E-C. Sec. Okay, perfect. So you have that on your unit circle. We're going to kind of go into that a little bit today. In my last class, we got all of this page done, so I'm hoping we can kind of do the same here. You might be like, well, Miss White, that feels like a lot with a short amount of time. I promise it's going to fly because we're using our unit circles. We all have our unit circles out in close reference. Perfect. Now, on number 4, those are not angles that are on your unit circle. You should not have 8 pi over 9 on your unit circle. However, we are just worried about what quadrant they would be in and what sign they would have. So even if it's not like a perfect one that we're used to, if it's in the second quadrant, we can use our second quadrant rules now, okay? So let's look at that one, okay? So we're just doing some estimating. I don't even care really what the angle is. I just want to know what quadrant it'll be in. So for number 4A, it says tell the sign cosine of 8 pi over 9. What quadrant would 8 pi over 9 be in? Second quadrant. It's almost 1 pi. 8 pi, and you don't have to do anything that I'm doing except for the final answer, but 8 pi over 9 is almost a whole pi, so it's somewhere here in quadrant 2. Now, cosine in quadrant 2 is positive or negative? Negative. It's negative, right? Because what's the only thing that's positive in quadrant 2? Sine. So if I'm talking about cosine or tangent, they are negative. Let's do sine of 152 while we're at it. What quadrant is 152 in? 2. It's in quadrant 2 again. What's my sign in quadrant 2, positive or negative? Positive. Because in quadrant 2, my S is there, so that's what's positive. Sine is positive. Okay, cool. Now let's do a couple negative angles. Cosecant of negative pi over 7. Okay, where would negative pi over 7 be? We're not going up pi over 7, we're going backwards pi over 7. Is that more than a half or less than a half? It's less than, right? So it's somewhere in the 4th quadrant. We only went down a tiny bit. It's just right about like here. We just went down a tiny bit. So I'm in Q4. Now we're going to have to do a little bit more work because cosecant isn't one of the ones that we said on the board until we wrote it with our reciprocals, right? Cosecant goes with which function? Sine. Good. 1 over sine. And it doesn't matter if it's 1 over sine. It just follows the same rules as sine. So if I'm in quadrant 4, is sine positive or negative? What is positive in quadrant 4?
Sine.
Cosine. So if cosine is positive, what's sine going to be? Negative. Good. Okay. Now let's do tangent of negative 200. Okay, so that means we're going in the negative direction 200 degrees. What quadrant will that take me to? 2. I'll go past 180 and I'll go somewhere in quadrant 2 because we're going that negative 200. In quadrant 2, is tangent positive or negative? Negative, right? Because what's positive in quadrant 2? Sine. Good. So everything else is negative. Wait, can you repeat it? Say again. Can you repeat what you just said? So I said, we figured out this was in quadrant 2. And then I said, what is tangent in quadrant 2? Is it positive or negative? I don't have any rule on tangent, but I know in quadrant 2, only sine is positive. So I'm going to assume everything that's not sine or cosecant, the reciprocal of sine, is negative. All right, we're still kind of working this brain puzzle out, but these next couple angles are bigger than 360. So just like we learned yesterday when we were doing our coterminal angles, we can go around once and then around a little bit more. So let's figure out where 25 pi over 8 is going to be. We do that by first minusing off 360. Let's get it into numbers that we're used to seeing. When I minus off 360 or 2 pi, or in this case, 16 pi over 8, is everyone okay with why I'm doing 16 pi over 8?
Why?
16 divided by 8 is what? 2. And we know our unit circle goes to 2 pi. So we're going to minus off 2 pi so it can be in numbers that we're used to seeing. 25 minus 16, is that 9 pi over 8? Yeah. Okay. What quadrant is 9 pi over 8 going to be in? Is it more than or less than a pi? Yeah. A little bit more than a pi, so it's going to be in quadrant 3. Essentially, what we did is we went around once, and then we went around a little bit more than a pi. Oh, come on. And stopped right about there. Now, cotangent in quadrant 3 is what? Positive. Because we know tangent in quadrant 3 is positive, and cotangent and tangent line up together. Okay, last one is a degree. It's a secant of 500. Let's first get this in terms of angles that we're used to. So I'm going to minus off 360. Is that 140? So when I draw this angle, I'm going around once, and then where am I ending up? In quadrant 2. Secant, now we have to remind ourselves, is 1 over what? We want it to be sine. Cosine. It's not cosine. Oh, it is cosine. Sorry, I don't know why I said that. It is cosine. I messed up in your class the other day too. No, it was with Ian, and he's now in C period. I really messed. I was like no, and he was like yes, and I was like, oh my god, you're right. I had to do like an apology tour. 1 over cosine, and cosine is what in quadrant 2? Negative. Because in quadrant 2, only sine and cosecant are positive. Okay, we're going to talk more about the importance of this later, but while we have our unit circles out, I want to do a little bit more practice with this. Tomorrow, which in our case is not till Monday, our tomorrow is not until Monday. I don't see you actually tomorrow. On Monday, we're doing more practice with fourth 1, 4, 2, 4, 3, but I want to do a little bit more of this using our unit circle because I don't think we've really hit that hard enough now. So we're going to do as many of these problems as we can in the next 13 minutes. And I promise some of them will take a couple steps, but some of them will be very easy look and check. Because next week we got to know the unit circle. So we're going to practice using it now so we can start finding some patterns, okay? On all of these, they say evaluate exactly, no calculator. That means I want radicals, I want fractions, I don't want decimals. Okay, so we're going to start, and I will walk you through as long as you want me to. If you're like, we're good, I'll stop talking. But I'm just kind of telling you my thought process, and you don't necessarily have to write down all the work, but this is what I'm thinking. Sine of 150, okay? First thing we're going to do is go to 150. Second thing I'm going to remember is sine is which one? X or Y? Y. So I'm looking at the Y at 150, and my Y at 150 is 1/2. So sine of 150 is 1/2. Okay. Sometimes it's that easy. Now the next one, we got a little bit more work to do. This one says cotangent of 5 pi over 3. Can you find 5 pi over 3? I found it. 5 pi over 3, we're doing cotangent. Well, we know cotangent is the reciprocal of 1 over tangent. And if tangent is y over x, what is cotangent going to be? X over y. Very good. So cotangent, we're going to do x over y, which in this case is going to be 1/2 over negative root 3 over 2. Okay, we played around with this the other day. Remember, if you've got a fraction, we're going to multiply by the reciprocal of the denominator. We're going to cancel out those 2's. So I get 1 over negative root 3. And I do want us to rationalize, so multiply by root 3 on top and bottom. So we get negative root 3 over 3. Now, as we memorize the unit circle, you may not have the whole unit circle memorized. You may just know like 5 pi over 3 is a 60-degree angle because anything that's pi over 3 goes with 60. And you may know the ordered pair at 60 is 1/2 root 3 over 2. The reason we just did all students take calculus is what we can decide is depending on what quadrant this is in, we can confirm or deny whether we need a negative. So earlier today, I was doing this as C period and I forgot my negative and someone reminded me it should have been a negative at the beginning. I agree, but another thing you can do is say, okay, I know that 5 pi over 3 is in quadrant 4, and I know tangent and cotangent in quadrant 4 is negative. So you can do all your work out and just tack that negative onto the end once you evaluated where in your unit circle it goes. Chase, did you not like that?
I'm taking
it. It's a lot. It's funny being up here because I see your faces, and sometimes you're just like, you take it very well, or I can't read your emotions, and sometimes like you're like, what is she talking about? Let me do a couple more, and we'll see if I can explain what am I talking about. Okay, cosecant of 3 pi over 4, can you find that? I found it. What quadrant are you in? 2? Me too. Okay, we're doing cosecant. Cosecant is 1 over which function? Sine, good. And so that's y. We're doing 1 over y. My y in this case is root 2 over 2. So I'm going to do 1 divided by root 2 over 2. Just like we were doing before, we're going to take the numerator and multiply by the reciprocal of the denominator. We get 2 over root 2, but we have to rationalize. So I get 2 root 2 over 2. And then I simplify even further, the 2's go away, and I'm just left with root 2. Now I can confirm for myself because this is a sine function and it's in the second quadrant, and we know sine is positive in the second quadrant, so I'm good. I didn't miss any negatives. Okay, let's keep going. Tan of negative 240. Okay, so we're going backwards 240 degrees. So I'm going back at 180, and then how much more from 180 am I going to need? 60. So that's one way to think about it. Be like, okay, I know I'm at one of my 60-degree marks. Another thing you could do is just add 360 to this number and get 120. That's the same as where we're at right now. So you should be at your 120 mark. Okay. And we're going to do tangent there. Tangent is what over what? Y over X. Good. So my Y here is root 3 over 2, and my X here is 1/2. Notice that's the exact same ordered pair we just used a minute ago. However, this time, since I'm in quadrant 2, my X is negative. So I can remember my negative here, or I can remember it at the end. I don't care. I am going to multiply the numerator by the reciprocal of the denominator. And the 2's cancel. And I don't have any rationalizing to do. It's just root 3. Now, as you do more of these, you may notice some patterns. I'm going to promise you right now that every time we do tangent of a 60-degree angle, we're going to get root 3. Whether or not it's positive or negative, anytime we do tangent of a 60-degree angle, we're inevitably dividing those two numbers in that order, so we're always going to get root 3. That might be a fact that you memorize instead of being like, oh, let me memorize the whole unit circle. If we can know that it goes to a 60-degree angle, you may just have this in your brain. Okay, so like there's not necessarily work I'm looking for. If you just remember this number, great. If you're like, Ms. White, I'm trash at memorizing, don't worry about it. We can always calculate it out, but we need to make sure we know our X's and Y's. All right, this one's an easy one. Cosine of 7 pi over 6. Cosine is which value, X or Y? X, good. And so my X at 7 pi over 6 is negative root 3 over 2. All right. What about secant of 5 pi over 4? Find 5 pi over 4. Oh, that's right next to 7 pi over 6. And we're doing secant. Secant is 1 over what? Cosine, and cosine is what? Yep, X. So 1 over X. And here my X is negative root 2 over 2. Wait a second, didn't we literally just do this? The problem above, do you see that we also did 1 divided by root 2 over 2? What did we get there? Root 2. This is, again, one of those patterns. You may not memorize that, but you may get to this point and be like, oh, I know that it's going to end up as root 2. Just don't forget that since it's a cosine in quadrant 3, it does need to be negative. This is where I'm telling us to work smarter, not harder. Kind of notice these patterns. Could I do all the work I did up there again? For sure. Do I want to? No, I don't. Okay, the last few are mostly quadrant angles. What are my only answers for quadrant angles? What are the only numbers you see for quadrant angles? For their coordinate points. Are you gonna get any root 3s on this? Nope. Are we gonna get any 1/2s? No, what number should I be seeing? 0 and 1 and -1, right? Good. So that kind of helps us narrow it down. So sine of 90. Go to 90. What's my sine of 90? 1. Perfect. It's your y value at 90. What about cosine of pi? -1. Good. It's your x at pi. All right. Tan of 3 pi over 2. That's going to be a tiny bit more work. But we know tan is y over x. What's your y at 3 pi over 2? Or yeah, 3 pi over 2. And what's your x? 0. What happens when we do a number divided by 0? Undefined. Good. When we start doing tangent, cotangent, secant, cosecant, we may get a couple undefined answers, and that's okay. Okay. Secant of negative pi over 2. Remember, we're going backwards. Where's negative pi over 2? That's positive pi over 2. Where's negative pi over 2? 270. Yeah, 3 pi over 2. And so I'm looking at my 270 degree, and my secant is going to be 1 over cosine, which is your x. What's your x at 270? 0. What's 1 divided by 0? Just like we talked about, undefined. Am I moving too fast? Okay, I've got one more. I want to skip letter K just for a second because it's not a quadrant angle. I don't know how it's snuck in there. Last one, easy one, cosine of 0. What is it? It's your x. Okay. We're done a couple minutes early. We're going to do this last problem. We're going to finish our 4-3 notes, and then I'm going to give you some practice stuff on Monday. Okay. We do need to have this unit circle know and memorize, know how to use it by next week. I don't remember when your quiz is, but I'll put it on Schoology. So let's make sure that we start working on that. Yep. I can upload a picture.